Which is coming
161.8. 161.8. I think it's
1.8.
huh.
Here, what is the okay? What we are getting is here is
Uh,
B
1 by root
cos
3.
30. Yeah. So we are getting 1 by root 3.
Yes. Into 2 into 3.14 into R is 12 into 10 raised to power minus 3.
To 10 to the power minus 3, right?
Yes.
Okay. Now, if you are multiplying root 3, you can use 1.73.
हाँ अच्छा 7.3 हाँ 7.1
What you are getting, you are getting 2 into 3.14 into 12 into 10 to the power minus 3. 10 to the power minus 3. Divided by 1.73. 1.73. It's coming
yes
0.043.
0.043
Meter.
into 10 raised to power 3
No, all I multiplied 10 to the power minus 3.
अच्छा
So it's coming final 0.043 meter. Now
फिर
I
in
can write
centimeter it will be 4.3 yes हाँ into 10 raised to power minus 3 4.35 yes into हाँ yes sir I did that 6.28 into 12 by 1 173. I got the same answer as well.
yes.
Okay.
Okay. So this way, a little bit calculation may be issue. Solve the questions, right?
Yes, sir. Yes, ma'am.
Just pay attention that when you are finding out the helical case,
हाँ हाँ
helical case, perpendicular component will give you the radius,
radius
and B parallel component will give you the basically the pitch and like how far it is.
that cos theta हाँ
So now let us discuss uh, this part, that is magnetic force on a wire carrying a current. Magnetic force
of wire carrying a
wire carrying a current. Magnetic force. Magnetic force magnetic force on a wire carrying a current. So the formula is that the force that will act on a current carrying conductor, that will be I L cross B. I is the current, B is the magnetic field. Let's say cross, 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 like that. Magnetic field is perpendicular to this plane.
Yes.
If a current carrying conductor is there, so when a current carrying conductor is there, your I current is flowing. You are keeping it inside this magnetic field B, and B is, let's say, perpendicular to it. So in that case, how much force it will experience? It will experience force. I L is the length of the conductor, and B is the magnetic field.
Okay.
And we can write cross product means sin theta will be there.
Right.
If L and B are, means length of the conductor and B are perpendicular to each other, so theta will be 90 degree.
Yes.
Then B is sin 90.
And you'll be. Okay.
And this is the concept taken from drift velocity. If you remember, from drift velocity is done, you have studied it previously.
Sir, I might have, but I don't think I remember.
So drift velocity is let's say like inside a conductor, the electron does not move in a straight path; it moves in a zigzag path. So the average velocity of the electrons are called drift velocity. Like with this velocity, the electron drifts or moves inside a conductor.
Okay.
So this is the average velocity.
Average velocity of electron moving in that conductor.
Write that we can write that this formula, how the formula come up. Now we can write that this conductor, the electrons are actually flowing here in a drift velocity. So we
Huh.
know that from Lorentz force. What is Lorentz force? That F
Uh,
is Q
it's
E cross B. This is the fundamental force actually. So from here, this force, this one is derived. We got. So here actually VD B cross. If a charge Q is flowing in a conductor,
huh.
current means charge is flowing, flow of charge, rate of flow of charge is current. So if the charge is flowing in the conductor, it will experience a force F equal to Q B cross B.
Huh.
Q B cross B.
B.
Now we can write this Q as we can write this Q like this. It is I into
T.
V. We can write L by VD again.
Um,
Write this F equal to Q is IT and okay, VD cross B, and this time we can write this is the length of the conductor. So to
huh.
cross
Distance. Huh. Into speed. Sorry. Speed is equal to distance. T is equal to distance by speed. Huh. Yes, sir.
so this is the length, and the electrons or the charges they pass in the conductor with a speed drift velocity VD.
VD.
So time will be how much time it will take to cross this conductor. So time will be distance by speed
Yes.
L by VD.
VD.
So we can write I T is L by VD, and this VD cross B we can write VD B sine theta. With this equal to we are getting I L B sine theta.
Yes. अच्छा हाँ.
I L cross B.
I L cross B. Yes.
So what is I L cross B? Basically, I L cross B is I L cross B is the what is I L cross B? I L
So,
cross B is the force on the conductor. That means when the conductor current is passing, it will create a magnetic field it's around itself, and that magnetic field will interact with the external magnetic field, that is B, and these two magnetic field they will interact. So either they will this conductor will get a upward force or a downward force. Like it will get a force, right? It will get a push or pull. Basically it will get a push or
sure.
pull force. So this is called the force on the current carrying conductor. If only conductor if will keep, it will not experience a force.
Conductor with magnetic field.
If the conductor is carrying some current and if
Uh-huh.
it is kept inside a magnetic field, then due to that magnetic field it will experience a
Force.
it will
I
experience a I L cross B.
L cross B. Understood.
So for arbitrary shape also it will work,
Mm-hmm.
but L, instead of L we'll write it is integration of dl and b.
DL and B. That's all.
Do like this: force on any arbitrary shape. So instead of a regular or straight shape, if suppose
Mm-hmm.
any arbitrary shape of conductor is there, so for that let us cut and make a small
DL.
straight.
Uh-huh.
Any arbitrary shape full length L. So basically you have to integrate.
Integrate, yes.
So what will be
Acha, only integration of the length, na? Yes. Yes, sir.
now we'll discuss. So we'll discuss now torque. And
Okay.
before that, one concept is there: force on a closed circuit in a magnetic
Uh-huh.
field. So for a closed circuit, it will become zero. For a closed circuit, because the vector sum for a closed circuit. Suppose this straight line, it's let's say it's a closed circuit. So for closed circuit, like the vector sum of all this L, the vector sum of all here and here, they will become,
Mm-hmm.
some are positive direction, some are opposite direction, so the vector
Opposite.
sum will net vector sum will become zero.
Zero. Huh.
Suppose on a similar situation it will become zero.
Zero.
Right. Force on a closed circuit in a magnetic field is zero. For a closed circuit.
Field is zero. It's written.
So now we'll discuss. torque on a current loop? Torque on a
Current loop.
torque on a current loop. So what is torque basically? What is torque? Torque is angular force.
Yes.
If the object is rotating, then the
It will.
force on it is torque, right?
Yes.
Angular force. Suppose this is the axis and this one is the object.
Mm.
It will apply a force on this object F, linear force, at a distance r. So basically it will start rotating about this axis.
Rotating.
So we use a symbol that rotational force as tau. This symbol is
Tau.
tau. Later like alpha beta.
Uh-huh.
Torque equal to r cross F.
R cross F. अच्छा हाँ. And force of load.
So it will experience a torque.
Yes.
Look how it experiences a torque, and this is a very important phenomena that led us the construction of motors, which has lot of application in our day-to-day life, like your washing machine, your
Mm.
fan, your anything you will see the rotated water pump, right? So it has a lot of application, and are actually advancement of this science and our utilities, the means construction or making of the motors. So here, what is the diagram basically? The diagram construction is like this. We will keep this current loop inside a magnetic field.
Okay.
So let's say this is the north pole of the magnet, this is the south pole of the magnet, and we'll keep this loop inside the magnet. So north pole, south pole means magnetic field lines will be from left to right, like north to south we know. So these are the field lines, P we can say. Now as we switch on, the current will flow in this loop. This type of loop are there inside a fan also, inside any motor, in terms of the coil. If you have seen any fan like opening, you will see that inside there are lots of copper oil like this.
Uh-huh.
Inside motor also you will see lot of copper oil. There are lots of loop. You will see any problem. If you can see that. So this loop here we have drawn a simple loop, single loop. So here current is flowing. Now the interesting thing is in the loop left side the current is moving up, but the right side the current is moving down.
Yes.
Left side the current is moving up, but right side the current is
move it down.
down. So as the current is moving down, as the current is moving down in the right side, so just now we read one concept, that is that if a conductor is kept inside a magnetic field, it will experience
Feel
a force I
like
B.
L cross B.
L cross B, basically any cross product means what? It's a perpendicular direction, right? Equal
Yes.
perpendicular to the
Okay.
left.
Hmm.
This vector is L cross B vector.
Yes.
So basically what the current is the direction of L also, same direction is
Mm-hmm.
the current direction. Now you are, if this is L, this is B is perpendicular to it. So L cross B will be, you just have to check with your right hand thumb rule. So it may be upward or it may be downward. I L cross B, you have to hold the current like I L cross B. So L cross B means just like this. You will hold it, so it will be upward. B cross L means opposite direction, downward. Right? L
Yes.
cross B and B cross L.
Opposite. Yes.
They are opposite in direction. So L cross B and B cross A are opposite in direction. So the interesting thing is that right side the current is down, left side current is up. So one
Okay.
side it will get, let's say getting, you will get the proper direction using the thumb rule. Let's say
Uh-huh.
the current is, the force on this left side is to the down inside, and this side the force is upward. So what it will do? One side down, another side up. So it will basically
Rotate.
rotate the, yes, it will basically rotate. So if you fix the axis here at the midpoint
Uh-huh.
or put some slip rings,
The
it will
rotate.
help the coil to rotate.
Huh?
Yeah. Then you may think that what about the current here? It's also flowing
Yes. But it is parallel to
parallel to
B.
B. That means
Sine
sine theta,
zero.
sine 0 will come, right?
Huh?
So no force is on this top and bottom. So it's not helping anything.
Yes.
It's not helping any
And
for the
in
rotation, right? It's not helping for the rotation. The rotation is helping by the left and right side, so it is getting a torque.
this.
Now we can use the formula, right? We can use the formula R cross F,
Cross of.
and we can write the final expression for the torque.
Okay. Okay. अच्छा, that F we got from the earlier equation.
I L cross B we
Huh.
got, and here we will write that this equation will write F equal to torque equal to R cross F, and R and F are perpendicular, so we can write RF sine theta or sine 90,
Yes.
right? So R into F, basically sine 90 is 1, so it's RF. Now R is basically the half distance here. Let's say this one having length L, right?
Which part, sir?
L1, L2.
Okay.
One is L1. This part is L1, the length, and this part is L2. So we can write L2 by 2 because R is L2 by 2 and F is L is L1, I L1,
One
V, I
cross.
ILV, right? Cross V. So L and V are perpendicular to each other.
अच्छा हाँ so one.
So this is what we can write torque.
Okay.
That I L1 L2.
L1 L2 B by 2.
So I L1 L2 by 2 into V, right?
Yes.
And this is the rotation for force on this one, and also this force is there also,
Oh,
right? So we have to add it. So this is, let's say, tau. So practically, if we'll analyze, actually we can add them, right? So
if we add them, won't they cancel each other? Cause direction is different.
for rotation case, if they will cancel if a force is applied here, if a
Uh-huh.
force on the opposite direction, then they will cancel.
अच्छा.
F and F here,
Mm,
opposite direction at a distance, then they
okay.
will not cancel out. This is
अच्छा.
called couple, means force at a distance, same force, same and
Mm,
opposite force acting at a distance. So this will have to help the object to rotate. It will
yes.
not cancel. If the force are acting same lines of force, then they will cancel.